This is a crash course in using LaTeX, so let's jump in and get started. So I'm starting here with a folder on my desktop called LaTeX. It's empty. First thing I'll do is create a simple text file, document.tex, and then you can edit that in your favorite text editor, anything you like. I'm going to use Vim here. First thing we need to do is put in a little boilerplate document class at the top, and we'll add some options here: letter paper and 11 point, and then we'll say that it's an article, which is a pretty standard format. And then we'll put in a \begin curly brace document and a corresponding end statement. And then we can paste in some filler text so we have something to look at, and that's it. So LaTeX is kind of an exercise in backslashes, keywords, square brackets, and especially curly braces. We'll see that quite a bit. So we'll save this file, and then we're going to compile this with, and you can see document.tex, we're going to compile this with PDF LaTeX, document.tex, and it does its thing. It creates document.aux and log. The one we care about here, of course, is document.pdf. And there you go. So I'm actually going to, this is how you typically compile it, is at the command line. There's lots of tools and graphical interfaces that can simplify some of those processes, including online tools like Overleaf. I actually have my Vim set up to be able to compile and view automatically, so that's what I'll be doing moving forward here. So let's add a little bit more to our document. So let's come in here and add a title, \title, and then some descriptive title of the work. And then if we save this, then we need to make title. So that sets the title. In order for it to show up, we need to issue this \make_title command here, and it shows up. And then it's also going to include the date, today's date. So you can put in the date explicitly if you want, and put anything you want, like April 1st, 2021, and it'll put in whatever date you ask for. If you don't want the date to show up at all, just delete it, delete the text in there, and then it doesn't show any date. Okay, so let's go in here and create some sections. Let's change this text here into an abstract. We go \begin abstract, and we can end this with end abstract. Then let's go and add a section also. So copy this. That's our abstract, and then let's add in like our introduction. So sections are added with \section, curly brace as usual, and then we can put in here maybe the introduction, and paste in our text. And let's go and add another section, like section maybe methods. Paste that in here. And for good measure, we can also add like a subsection to this. You do like a subsection, and you can do subsection, etc. Like numerics, for instance. Let's put this in. Okay. So then when we look at our document, you can see that it's formatted things for us. We get the abstract is a little smaller font and a little bit narrower, and then we have the intro, the methods, numerics, and everything is automatically numbered for us. So that's nice. Okay, so let's see here. So if we come up and you'll notice that the document's got a pretty wide margin. It's not using all of the page by default. That's annoying. LaTeX can include a lot of packages, and if you have a full LaTeX distribution, you'll have all these installed as part of LaTeX. So let's do use package, full page, and then if we recompile this, then you can see it's going to fill the page up. So very nice. Okay, there's a few other packages that we can use. One that's convenient is this auth BLK, and we can do some author formatting here too. So if we put in like author Lignell, whoops. There we go. Then it puts in the author here at the top. That can be done without this auth BLK package. But the auth BLK will let us do something like put in like an affiliation for the author. So if we want to put in like a fill, let's see here, like an affiliation 1, that'll put a superscript 1, and then I can put the school Brigham. University. And then when we save this, it puts a little superscript with the affiliation, and you can put more authors here. Jane Doe, and she gets to be at my other favorite university, the University of Utah, and then you get both affiliations show up. So that's kind of nice. Okay, a few other packages that are useful. Let's do maybe AMS Math and AMS Sim. These will add some extra math functionality and symbols you can use. BM for bold math, if you want to make bold symbols, for instance. We can put line numbers, line no here. We can do another one that's pretty useful, and is for figures. If you want to include figures, we'll put in graphic X. So that's a few of these packages, and usually you'll just put in a bunch of them so that you have them all the time. There's quite a few. You can look up the various packages quickly. So at this point, it's good to visually separate your document with Workspace or with white space. So I'm going to go in here and just percent symbols are considered comments in LaTeX. I'm just going to add a few of those in here to separate out the various sections that we've got. And then at the bottom. Good. So now these sections that we have can be labeled so that we can refer to them later. So if we put in a label, and then curly brace, and then the label that we want to use, and you can put in any text for the label that you want. I'm going to put in L:intro, and the S:intro. The S is going to refer to a section. And we can label equations and figures and tables, so use things like S and F and E to refer to the different things. And this is just a helpful visual guide to keep the labels separated in the categories, but not required. So then anywhere we want in the text, maybe down here in the methods, we can go as shown in section, and then give a reference, ref, and then put in the label, S:intro. We show, anyway, your following text. Then when you save this, you can see that it's going to put in section 1 and number it appropriately so that it's whatever make sense. So we can do the same thing with our subsection, section that, and section. Let's put in the reference for the subsection, ref, and we haven't labeled that yet, but we'll label it in a second. Just call it my subsec. So, and down here in the subsection, we'll give it a label as my subsec. So, okay. And then you can see it's going to auto label 1 and section 2.1. And if you move sections around, the labels are still, everything's going to be continue to be numbered correctly. So this is great. Okay, so let's go and add some citations to our document. So for the citations, we're going to want a new file called, you can call it whatever you want, but it's going to end in a .bib. So we'll do touch references .bib. And then let's edit that, references.bib. And for that, I'm just going to copy in a reference from a previous database here. And this will be in a bibtec format. It's going to have @article because this is an article type reference, and then curly brace, and then we give it a key. And this is how we'll refer to this particular reference in our document. And then, so you can do this in various ways, but when you have a lot of references, it's good to have a system. So a common thing to do is the author's last name _ year, and then you can put in then you'll have a comma separated list of keys here. Author equals curly brace, and then your author is separated by and then for the title you'll have curly braces for the title, journal, year, volume, pages. Don't care about the file. Let's put in another one. We'll do maybe a book reference here. And the fields are a little different depending on the type of the reference. So we have one called Botkhorn 1994 and Lignell _2007A. And then we can look at our document again and put in citations. Those go in fairly easily. Let's put them at the end of the introduction here. And \cite, and then the citation 7A, I think was that one, and Botkhorn 1994. Okay. And then when we run this, oops, there were undefined citations. Let's look at this again. References.bib, of course. So that's not enough. We need to actually document tech. So let's go down here to the bottom and put in our references. So at the bottom of this page, we'll put in \bibliography style, and then the style that you want the references to show up as. So I'm going to use this UNSRT style, and this is just going to show numbered citations that go in the order of that are numbered in the citations list in the order in which they appear in the document. And there's several other options that you can use there. And then the other one that we'll do here is our database references, and we'll leave off the bib file. Okay, so once we save that, then it's gonna, so you can put as many references as you want in this references file. The document's only gonna include the ones that you explicitly cite in the document. Okay, and then we can see it updates this with the 2 references and auto formats them down below. Now, one thing that's easy to sometimes you need something to be capitalized in your title here. So let's go ahead and capitalize flame. And when we do that, we see that flame is not capitalized, so it ignores the capitalization that I put in the references. So if you want to force that capitalization, just surround that with a curly brace, and then we can see that in fact it capitalizes the word. So that's something that's really easy to miss. Sometimes you'll have acronyms and titles that you want capitalized, and if you don't put them in curly braces, then it will not pick it up in your reference list, depending on the format style that you use for the references. Okay, good. So let's go ahead and add in some equations and show a little bit about how that works. So equations can be added inline to the text or as separate lines that stand alone. So an inline equation is going to go between $signs. So here is an inline equation, and that's going to be $, and then you can type your equation A equals B, $. This is at the end of the introduction here. So A equals B. And then if you want an equation on its own line, we're going to do that between square brackets, like so. And we can do A equals B. And then this shows up on its own line. So if you want Greek letters, you just spell those out. So like f of x equals /alpha, and that'll work fine. And if you want an uppercase, like f of x equals like delta, capital \capital delta, like so, plus gamma, lowercase gamma, then you can see how it formats those. So uppercase, lowercase, easy. And then things like superscripts and subscripts, f underscore. So if you want an underscore character f of xi, you can do that. So delta, okay, we'll just do delta xi. It pretty much ignores white space in the document, so you can put as many spaces as you want. That's not going to show up in the formatting. But you do need to put a space between like the delta and the x so that it recognizes delta as its own word. So delta x underscore I, that'll give us a subscript. Let's do that again. So you get a subscript, and then a superscript is going to be this little hat character here. Power symbol sometimes. Squared. Okay, so subscript, superscripts. And if you want to put more than one thing, so maybe it's x max, if you do that, it's only going to catch the first letter. Only the n gets caught. So that's awkward, and it's easy to make those kinds of mistakes. So if you want the whole thing to be a subscript, just surround it with curly braces. So, and then we can see that subscript. Okay, so let's put in some fractions. Fractions going with \frac, and then in curly braces for the numerator, and curly braces for the denominator. So any valid LaTeX can go in here, a plus 5 divided by 2, for instance. And that can include other fractions if you want. So we can put in another frac. And, \alpha plus \beta 3, for instance. Okay, so fractions with fractions. Okay, so we can do things like make integrals \int, and then the lower bound of the integration will be an underscore, and the upper bound of the integration will be a hat there, and something like xy squared dy, and you get an integral. You can guess what happens if you change this into sum. Okay, this will make a summation symbol, like so. Okay, great. So occasionally, if you want parentheses around things, you can put in parentheses, curly braces, square brackets. You'll notice if you put in these parentheses that the parentheses aren't as big as they should be, kind of small. So to make them the right size, you want \left, and then parentheses, and then backslash, oops, you want \right, parentheses, like so. And of course that works for the various types of braces, curly braces, and whatnot. And then it gives you a nice large parenthesis like you want. Okay, so this is an inline or a separated equation on its own line. You can change this to but it's not numbered in the text. So if we do begin equation and end equation, then it's going to give us a numbered equation. And then this can be referenced, so we can label this equation, like fx, for example. And then you can refer to it wherever you want. So equation /ref bfx shows, okay, and then that'll be automatically picked up and numbered as part of the text here. Equation 1 shows, and then if you add equations or insert whatever, they'll be automatically numbered. All the equations will be numbered in order whether or not you label them, but labeling them is a way to explicitly call out the reference later in the text. Now you can see that the equation kind of starts to run into your text and be not as visible, so it's good practice to add a little bit of white space, but if you do that, it's going to force a new paragraph. So maybe you want the equation and you want to continue without making a new paragraph, and if you add space around it, it'll make new paragraphs. So the easy thing to do is just put a blank line with a comment. That visually separates the equation, makes it a little bit easier to read without doing anything to the format of the document. So you can put the equation in line. And of course you'll want to, depending on how you are writing your document, formatting equations can be useful. Okay, so there's a little bit about equations. One more thing here, you might sometimes see plus functions like sine. If you do like sine of x, you'll notice that it's going to put sine as variable s times variable I times variable n, which is awkward. So what you want to do instead is just \sine, and that will convert it to a nicer looking sine as a function sine. Same thing with cosines, tangents, exp, logs, etc. So that's a good thing to know about. You can find out a lot more for how to format and use equations online, and there's 1001 special symbols. So it's easy to get access to those that are all going to have their own thing. So if you want an arrow, for instance, it's going to be like \right arrow, and there's a corresponding left arrow, right, left harpoons, all kinds of different arrows, etc. that are available. Okay, so let's go ahead and add in a table. Show the basics of the table, and we'll just put that here. Then I'll copy that from an existing table so that you can see what the format looks like. So we begin a table environment, begin table, and And then we're going to put in this caption, \caption, with the text that goes in the caption, and then the label is going to go after the caption. Here, T:, give it some label, and then centering it on the page. And then we begin, inside this begin table, we begin this begin tabular environment. And it's going to have this curly brace with LLL. So for every column that you have, you're going to want either an L or a C or an R, right, left, center, for how you want the column to be formatted. You can do a \h line to show horizontal lines in your table. And then within a row, the rows are separated by this double backslash. That'll make a new line. And then the columns within a row are separated by ampersands. So that's the basic format and layout for a table. It's easier to write and read your table if you go out of your way to line up the ampersands and the backslashes. And there's lots of tools that will create tables for you to help do that. You can find them online. There's tools to convert Excel tables into LaTeX tables, and that can be pretty convenient. So let's go ahead and see what this actually looks like. So there you go, and you can see 3 horizontal lines where we put them, H line, H line, H line. And some of these include equations or text. All of that's fine. Okay, let's put in that's a table. Let's go ahead and put in a figure. So maybe down here. Now, some of this boilerplate can be hard to remember and type all of that. A lot of graphical tools will have that built in. Click a button, it'll insert a table for you, and you can fill in the details. There's tools in Vim to help you do that with snippets. So if I type fig and then my lever key with a tab, it's going to auto put in a figure for me, and then I can just make edits as I like. So the label, fig, and BI, and then the figure itself goes in this include graphics. You can tell it how wide you want it to be on the page. So there's a couple formats for this. This is 0.8 of the total line width, 80% of line width. You can also do an explicit size, like 3 inches, and then the name of the figure. So let's copy a figure over into my document here. And I'll just grab all those. So I'm copying 3 versions of this. I have PDF, PNG, and JPEG, and they all look like PDF. This is what the figure looks like. Okay, so we'll just plop that in there. And MPI strikes back, do the JPEG version, copy that or save that thing, view it, and you can see it's on, there it is, and it's 3 inches wide. A PDF LaTeX is convenient because it'll handle JPEGs and PDF files and PNG files nicely. If you're using raw LaTeX, it's going to want EPS, and that's it. So you get a little bit more flexibility with PDF LaTeX. Also, it's going to put it as your final document as a PDF file, which is often what you want. So you can make this a PDF. And there you go. Okay. And of course, the size here, it depends a little bit on what you have. So what the size of the original figure, I think there might have been some white space around that JPEG when I did a simple conversion. Let's see what the PNG looks like. Yeah, you can see there's white space here, so you need to format this and crop it appropriately so that the figure does or doesn't include parts that you want. But that's just because of the conversion step I did to demonstrate that you can have different file types for your figures. Okay, this HTTPB, these are position codes. They're not required. You can leave them off. If I put, let's take it out and see what we get here. You can put, for instance, let's move the figure to be maybe in the right after the intro. Let's see where it gets placed by LaTeX. So it goes right before the table. Now you can force it to be in the location that you want it to be. If you do something like put this H, for example, we'll say put it here so that it corresponds to the document. And it'll do its best to try to force that location for you. I don't usually worry about it. LaTeX usually finds a good spot, which is fine. Okay. So these are some of the main things here. I guess we can show also in terms of this equation. Let's go ahead and just show one or two other environments that are convenient. Sometimes you want equations that multiple equations lined up, and the align package is good for that. So we'll do begin align with the corresponding end. Corresponding end of the line. And then we can write an equation like f of x ampersand equals x plus 5 backslash y and equals a plus b plus c plus d, like so. So what this is going to do for us is it's going to force alignment at the ampersand. So wherever the ampersands are, it's going to be lined up. And this can give you a little bit more control over how that looks. And then the double backslash will force the equation to be on another line if you want to put like a series of equations. So the align is really useful. Another thing that I like to use, sometimes you want to force white space, and it can be a little hard to do that with LaTeX. There are specific functions for that, like backslash comma. We'll add a little bit of white space to it. You can see some spaces there. You only need one comma. However many you add will add spaces, and there's other symbols besides comma that work for that. But one that I find really useful is this phantom, A, B, C, D, E, F, G. That will put in space as if I had A, B, C, D, E, F, G there. It just doesn't let those show up. So that's kind of a nice little hack for forcing white space, is to use this phantom. Okay, so anyway, there's tons more to learn about LaTeX, but that will get you going pretty well, actually, and then you can look up more details online. Thanks.